We're now going to look at a specific example. And so our goal in this problem is to determine the average value of the function f of x is equal to x squared on the interval from 0 to 9. Let's start by graphing the function. 0, 0, 1, 1, 4, 2, and 9, 3. And if you have a picture of the function, it is useful to think about what the average value is going to be close to before you actually calculate it. So for instance, if this had been a linear function, its average value would be the average of the 3 and the 0, so it would be 1.5. However, since this is concave down, it's got more area than the line would, and so we know that our average value is going to be a little bit bigger than 1.5. Here we go. So the average on the interval 0 to 9 is equal to 1 over the change in the x values multiplied by the integral of the function on the interval from 0 to 9. And let's put this one together by hand. If you take the antiderivative of x to the 1/2 power, you get x to the 3/2 times 2/3, which is the same function we saw in the first example today. And we're going to tie that in just a minute. No need to plug the 0 in because you'll get 0. Plug the 9 in, we get 1/9 times 2/3, 9 to the 3/2. 9 to the 1/2 power is 3, so this is 3 cubed. Cancel that with the 3, you get 3 squared, which cancels with the 9 right here. You're left with that 2. So our answer is 2, is the average value of the function. Here's 2. And so again, what this tells us is that this box that I just drew, and that I'm now shading, it has the same area as the definite integral from 0 to 9, the same area as this. And we should note that the value that makes the mean value theorem for integrals true is this x value right here. We can see from the graph that that value is c equals 4. If we wanted to solve this problem algebraically, we could say this. Well, the average value of the function is 2, and the function is x to the 1/2 power. What value of c will make this statement true? And the answer is c equals 4. Here's the tie-in. In this particular example, we had a function, square root of x, and we wanted to know what its average value is. Its average value is 2, and we wanted to know where it attains that value, at 4. Now look back at the first page of your notes. What you should notice here is we had a function where its derivative was square root of x. The average value of that derivative is the secant line of 2, and it attains that average value at, what do you know, 4. Math is crazy.